And I'm Nick.
And this is CAD Micro TV, and we're here at the CMTS show at the Markforged booth with one of our favorite guests, Mr. Jon Reilly, who is the VP of Product. Hi, Jon.
Hi, nice to see you guys again.
Nice to see you. So, Jon, the last time we saw you was in LA at SolidWorks World.
That's correct.
So I guess we can just start off here. How's business been since we last spoke?
It's been great. We've been growing incredibly fast, and particularly in the manufacturing space, which is why this show is like a really great opportunity for us to tell people about what we do. I'd like to walk you guys through some of the different customer part examples we have here at the show and show you some of the great things we can do for your business in the manufacturing space.
All right, well, let's get to it.
Okay, so this is an example of a CMM work holding fixture. Here we have a connecting rod. You would, in the manufacturing process of this connecting rod, need to perform an inspection on it to make sure it's exactly toleranced correctly. Previously, this inspection fixture was made out of aluminum. It was CNC'd. It cost thousands of dollars. It used to also have these vertical location fixtures pieces that had cutouts. We were able to print the thing for $50. It locates incredibly easily. You snap it into place and now you can perform your CMM operation. You get the part faster and you spend a lot less money and time on creating the fixture to hold the CMM. It's not just work holding for CMM fixtures though, but even operations like welding. This is a weld fixture that would previously be CNC'd out of aluminum. We've printed 3 different parts to hold an incredibly awkward angle together so you could weld these 3 tubes. You could also print this in one continuous part. The material cost that goes into this print is something like $30. It's an order of magnitude cheaper than you would have spent on machining aluminum and ready the same day. So it's changing the way you workflow. So now your machine spends its time doing critical machining tasks instead of working on fixturing for your actual parts.
Right. What do we got over here?
So this is a robot jaw end effector. As manufacturing becomes more automated, a lot more robot arms are in the process. If you walked around the show, you'll see them everywhere, even moving around K-cups. In this case, Dixon valve and coupling. They make these valve and coupling parts. They used to CNC their robot end effectors out of aluminum. They bought from a service bureau 30 different 3D printed parts to see which ones would survive on the 110-pound force on the end of the robot jaw. Only the Markforged parts passed the test because we reinforced them with continuous fiber. They then put them in their cutting fluid bath. Because we're made out of nylon, we were the only part to survive the bath. So for 2 reasons, we made sense for their application. They saved 97% of the cost versus how they were previously making them. For the 3 that go on the end of the robot jaw, that's like $1,000 per instance. Wow. And on every project that they use us on, they say they save around $36,000. So one of the key things about our machine that makes it different from other 3D printers is that we have a real ROI, a return on investment that happens in months, not years. You can do the math and see how quickly you're going to get a return, and that's why we're getting so much traction in the market, because the value is there. Yep. And then finally, this is a soft jaw for work holding on an airfoil. Again, like you would traditionally CNC the holding pieces out of aluminum, you're able to print them now, saving time and money.
Wow.
But there are, of course, certain applications where a composite part, even a plastic part, is not going to cut it. Those are applications where you need really hard surfaces or high temperature resistance. In that case, we talk about metal. And so this is that same soft jaw, slightly different step in the process. If you look inside of this part, you can see that it has threads. And so for this application where the robot arm comes inside and picks up against the threads, it's too sharp and it was cutting through the plastic.
Okay.
So that's where you pick metal. You need the hard surface finish. And so this part can come inside, run against these threads all day long and not have any problems. This part is actually cheaper. It's made out of stainless steel, and it was about, again, an order of magnitude less expensive than if they'd machined it out of stainless steel. Stainless steel is hard to machine, especially complex geometries. So that's the value proposition we get. One bonus part here is a titanium bottle opener that we've made.
Oh, we like bonus parts.
We're winning. There we go. Take a good look at that, guys.
And it's incredibly light, right? It's
incredibly light and incredibly strong. Oh my gosh.
That's what you get.
So talk to us about the product lineup and what has changed since last time we saw you in LA.
Yeah, we've made a lot of progress in the lineup since then. On the composite side, we now have a full series of industrial printers, so you can cover basically every price point from $35,000 up to the $70,000 X7. We've renamed the Mark X to the X7 and introduced basically 2 printers, the X3 and the X5. The X3 will print carbon fiber reinforced nylon, so the onyx material. And then when you step up to the X5, you get continuous reinforcement with fiberglass. The X7, of course, at the top of the line gives you carbon fiber and Kevlar reinforcement. So now you can choose the exact right printer for your application and your needs. And the best part about it is we have an upgrade program, so you don't get penalized if you pick a printer that's lower down the line and later decide that you want to move up.
Okay.
You can do so.
I like that.
It's not as cheap as if you bought the higher end one to start with, but it's not bad. We want to make sure that you get to the printer you need at the right cost. On the metal side of the business, we've introduced an entire suite of post-processing equipment. So now you can go from art all the way through the process to part entirely on Markforged equipment. So that's a washing station, which takes the printed part and washes out half of the binding material, and 2 options for furnaces, the Sinter 1 and Sinter 2, that can then sinter that part into the fully dense final metal form that you see here.
Wow, you guys have been busy.
Yeah.
Really busy.
It's been incredibly busy.
Wow. Well, thank you so much, John, for spending a little bit of time with us and giving us a sneak peek into what's coming down the pipeline for Markforged in 2018.
We surely appreciate your time, and if you'd like more information about CAD Micro or Markforged, you can write to us at sales@cadmicro.com.
And don't forget to follow us on Facebook, Twitter, YouTube, Instagram, LinkedIn. I'm Nick.
I'm Sarah.
We'll see you soon.